Now for some key knowledge. Have you revised this topic yet? For this topic, it would be advisable to have a periodic table and to have good knowledge of the periodic table. Highlighted on my periodic table are where the metals are and the non-metals are. Bonding between metals is metallic. Bonding between non-metals is covalent. And bonding between metals and non-metals is ionic. Always make sure that you use the periodic table, especially if you're unfamiliar with substances. It is advisable before you enter into your exams to have good knowledge of different structures. Metals, ionic compounds, simple molecules, and giant covalent structures such as diamond and graphite are often asked about in exams. Pause the video and go over these. Time for a question? Question 1. Titanium chloride is a liquid at room temperature. Explain why you would not expect titanium chloride to be a liquid at room temperature. Pause the video and have a go. So how did you get on? So the first thing to point out, if you're unfamiliar with this substance, I'd be looking at my periodic table. Titanium is a metal. Chlorine is a non-metal. So this is an ionic substance. What's unusual about that is that it is a liquid. I would expect it to be a solid. Okay, so explain why you would not expect titanium chloride to be a liquid at room temperature. So first point I would make is titanium chloride is ionic. Second point, ionic compounds have high melting points. And finally, I would put that there are strong forces of attraction between the ions. Three bullet points for 3 marks. Check my answer, check your answer against the GCSE mark scheme. So metal chlorides are usually ionic. There is a mark given for saying they have a high melting point and they have strong forces between the ions. Didn't need to mention electrostatic, that's in brackets. Question number 2. So we are looking at graphite. So we are looking at a giant covalent. So if you haven't already looked at the table, look back and get yourself familiar with giant covalent structures. What we also can see is that this question has been split into bullet points. So use these bullet points as headings to structure your response. Okay, it also wants us to talk about structure and bonding. So do not write about the properties in this answer. It's a 6-mark question, 2 headings, a good electrical conductor, soft and slippery. So as suggested, I would split this question into 2 parts, a good electrical conductor and soft and slippery. I'm going to focus on the soft and slippery part of the question because I think the diagram informs this better for me. So, as I can see from the diagram, there are layers. So I could write down it has a layered structure. However, what the diagram doesn't show me is that there are forces of attraction between the layers. I know those forces are weak. So I'm going to write that down. Weak forces of attraction between the layers. And because there's weak forces of attraction between the layers can slide over each other. Now I've done that part of the question. What would you write for the other part of the question? A good electrical conductor. Maybe pause the video, have a go if you haven't done so already, and then check against the GCSE mark scheme. So here's the GCSE mark scheme. Remember, my focus was on the soft and slippery part of the question. I talked about graphite being layered. I talked about there being weak forces of attraction. And I talked about the layers being able to slide over each other. I made relevant points and I made links between the points. This could have helped me achieve a level 2 answer. However, I did not talk about graphite being a good conductor of electricity. Relevant points needed to be made with links to help us achieve that level 3 answer. Question 3. Again, a question looking at bonding and structure. Explain why chlorine, Cl2, is a gas at room temperature, but sodium chloride, NaCl, is a solid at room temperature. Again, use the substances to provide you with an easy structure to your answer. So, column for chlorine, column for sodium chloride. Because it's about bonding and structure, do not write about properties. Pause the video. It's a 6-mark question. See how many points you can make. So here's the GCSE mark scheme. For chlorine, chlorine has covalent bonds between atoms, forming simple molecules. There is a weak attraction between the molecules and it has a low boiling point. Sodium chloride, however, has ionic bonds, or you could say electrostatic attraction, which are strong and they are in all directions. This is between oppositely charged ions and will form a giant lattice. Large amounts of energy will be needed to break these bonds. Therefore, it will have a high melting point. Question 4. We've been provided with a table showing the structures of 3 compounds: carbon dioxide, magnesium oxide and silicon dioxide. For the question, compare the structure and bonding of the 3 compounds. Now, when you come to a compare question, it means to talk about the similarities and differences, not just to write about one. So using the compounds as headings is probably not the best way to structure your answer. Instead, I will structure my answer using a table. Pause the video and produce your own table for this question. So how did you get on? Did you construct a table as suggested with structure and bonding as headings? Here's my table. structure and bonding as my two headings, and then similarities and differences down the side. So I'm going to start with carbon dioxide. Carbon dioxide is made with two non-metals like silicon dioxide. This means they are covalent. So a similarity given whilst comparing carbon dioxide and silicon dioxide. What would you put in my other parts of the table? Or what have you put in your table? If you haven't completed a table yet, maybe it's time to pause and attempt this question again. Once you have completed the question, move on to the GCSE mark scheme. So here's the GCSE mark scheme. Remember, we want to secure a level 2 answer. For that, scientifically relevant features are identified, the ways in which they are similar, difference is made clear, and the magnitude of similarity difference is noted. So if I was looking for my question, there we go. Carbon dioxide and silicon dioxide are both formed from non-metals, so that's important, they are covalent. What else have you put in your table? Can you identify this on the GCSE mark scheme?